Okay, so today we're going to go over, like I said, density. So I'm going to try to keep this hopefully as, you know, easy to understand as possible. This document here on density, this is actually in your folder, but there's some stuff in here that we're not going to cover because we would have covered this if we were in school. And I spelled mass wrong. If we were in school and we were playing around with some instruments to measure mass and measure volume. So obviously we're not at school, so we're gonna skip this. I will talk about it a little bit, but for now I'm just gonna skip this. I'm gonna explain this a little bit later, what this is. So I'm just gonna go down to just defining what density is and how to show you how to calculate density. Okay, so in terms of mathematically, it's not very hard. It is a physical property. We talked about this last time. A physical property is a way to describe matter. It doesn't require you to change or rearrange the atoms in any way. You know, it's, if you remember, like you can describe things like how well it conducts electricity. You can talk about if it's malleable. You can talk about whether it's shiny, lustrous. Density is one of those physical properties. And it's a very, for me, a very important one. Now, it's defined as mass over volume. Let me just omit some people here. Hold on. Okay, two people came. Okay. So density is defined as mass over volume. So if you remember in elementary school, you might have done like these magic triangles. So we could say density is mass over volume. So this is a neat way to help you remember how to solve for certain things, because you can see in this equation that D is M over V, like you're seeing right over here. But then we could also use this as a way to help us, you know, come up with different equations. So for example, maybe I'm not going to ask you for volume instead of density. Maybe I want the volume. So in that case, the volume would be the, according to this, the mass over the density. Or maybe I'm going to ask you for the mass. And in that case, the mass will be the density times the volume. Okay, so I think I have an example of each one in this little problem set. So we're going to do 4 questions on density, all right? So let's start with a really simple one. What we're going to do is we're going to calculate the density of a metal object, which means that we are going to have the mass and we're going to have the volume. So according to this, we have an object that has a mass of 1,100 grams. And it has a volume that we'll actually need to calculate. So sometimes it's a little bit straightforward. You have the volume already provided. Sometimes you don't. So in this case here, this is a rectangular object, rectangular solid. It looks like this, which has dimensions of 10 by 4 by 5. So you probably did this, I think maybe in elementary school, maybe grade 9 math, determine volumes of different objects. So in this case here, the volume of this object would be, you know, length times width times height. So we could say that the volume of this object would be 10 centimeters times 4 centimeters times 5 centimeters. Okay, that will give you a volume of about 200 centimeters cubed, okay? Because it's centimeters times centimeters times centimeters. So it's referred to as centimeters cubed, all right? And often, by the way, you should see that when you look at the way mass is expressed, usually you'll see it in grams or kilograms. I mean, it's not the only way to express mass. And the volume, you'll see, is often expressed in things like milliliters or centimeters cubed. By the way, these two are equivalent. So 1 milliliter equals 1 centimeter cubed. That's just, neat, kind of handy to know that. You can also express volume in liters. There are other units that, we'll probably come across, but these are very, very common ones. Okay, so the mass is 1,100 grams. The volume is 200 centimeters cubed. So the density is defined as the mass over the volume. So that would be 1,100 grams over 200 centimeters cubed. So the density should be 5.5 grams per centimeters cubed. Okay, so you see the way density is expressed is in mass per unit of volume. All right, so that's one example. Here's another one. In this case, we're not looking for the density, we're going to look for the mass. So we're going to try to identify the mass. So what we have is we have the volume. It says that the volume of this object is 100 milliliters. And the density is 3.5 grams per milliliter. Okay, right here. So from our little magic triangle, mass is density times volume. Sorry, hold on a second. One second. Okay, there we go. All right, so mass is density times volume. Okay, so in this case, the density is 3.5 grams per milliliter, and the volume is 100 milliliters. Okay, so now look, what's going to happen here is we have milliliters over milliliters, right? You have milliliters over milliliters, so they're going to cancel out. You're going to be left with grams, which is, what you expect because mass is expressed in things like grams or kilograms. So you shouldn't see any unit of volume in there. So this will give you then a final answer of 3.5 grams times 100, which would be 350 grams. Okay, so that's so the first question was, solving for density. The second question is solving for mass. Now the third question is going to be solving for volume. Okay, and if we're going to solve for volume, if we look at our magic triangle, our volume would be mass over density. Okay, so volume is mass over density. So what do we have in this question? We have the mass and we have the density. Okay, so the volume is the mass, 25 grams, over the density, which is 4 grams per milliliter. Okay, now you'll notice you have grams on top, grams on the bottom. So they are going to cancel out and you'll be left with just milliliters. Again, that should make sense because volume is expressed in things like milliliters, centimeters cubed, liters, okay? So we should be left with a unit that expresses volume. Okay, there we go, milliliters. So our volume is 25 over 4, which is 6.25 milliliters. All right, so there is an example for each scenario, right? Calculating the density as mass over volume, calculating the mass as density times volume and calculating the volume as mass over density. Okay, we'll just do one more example because I just want to do like a simple intro today. And then on Friday, we can do some more complicated scenarios, okay, regarding density. Okay, any questions? If you have any questions, just put it in the chat. Anybody have any questions about these three scenarios with regards to density, mass, and volume? I am recording this, so you know if you're like, oh, I forgot, you can always go back. Okay. Okay, so I don't see any questions, so I'm going to move on to the last example, and then I'm going to show you what you can try. Okay. Okay. So what if we have a sample of metal and we don't really know what it is? Now, you know, we talked about metals have certain properties. One of the properties is a unique density. So imagine you trying to figure out, you have a piece of metal, but you think it's either aluminum or magnesium, but you're not really sure because if you look at aluminum and magnesium, they kind of look the same. I mean, there are things you could do, like magnesium, for example, is combustible. It will react with oxygen. So you could burn magnesium. Aluminum wouldn't really, it would react with oxygen, but it won't burn. So it's, you know, it's not going to be the same thing. Now, what we could do in this case is we could use density to figure out the, hold on, I got someone who entered the waiting room here. What happened? Essence got kicked out. Okay, let me just admit her again. All right. So the what you could do in this case is use density to figure out what your sample of metal is. This, by the way, if you're, I don't know if you know you might have heard the story about Greek named Archimedes. So I don't know how true this story is, but I came across this, and I think you've heard of it. There was a Greek named Archimedes who was trying to figure out whether or not a crown that he paid someone to make for him was made of pure gold. So what he did was he used density to figure out whether or not the crown was made of pure gold, kind of like what we're going to do right now. Okay. Okay, so here's the idea. The idea is, let's imagine we have an unknown substance. We have its mass. So its mass is 24 grams. And we have its volume. And its volume is 8.9 milliliters. If we could figure out its density, then we can determine if it's aluminum or magnesium. Okay. So we're just going to simply plug this into the density equation. Now, there is something that in the question that says use a displacement method. So I will mention that really, really briefly. We'll talk more about this on Friday. So here's the problem. If I have an object that looks like this on the left or like the one on the right, like how would you get the volume of that? Because I mean, if it's a cube, we know how to get the volume of that. We know how to get the volume of things like cones, spheres, but how would you get the volume of something that is so irregular like that? So, well, we'll talk about this on Friday, but you can use something called a displacement method. The idea is really, really simple. You take, you fill up a container with water with nothing in it, and then what you do is you drop something in it, and what's going to happen is the amount of water, the level of water will change. So, for instance, let's say we look right now and we see that there's a container and it's got about, I think this is, milliliters. It's got 20 milliliters of water. And then we drop something in, maybe we drop a rock in. And after we drop the rock in, the volume is, it looks like it's between 30 and 31. So we'll say it's like 30.5 milliliters, right? So that change in volume is the volume of the rock. So that difference between the 30.5 and the 20, that's the volume of the rock. Because it would be very difficult for you to measure the volume with a formula for the rock using, because it's not a cube, it's not a pyramid, it's not a cone, it's not a cylinder. So, what would you do in that case? You would use something like the displacement method. So going back to the story about the golden crown, apparently Archimedes, figured out by dipping the crown into some water, he was able to figure out that the density of the crown did not match the density of pure gold. So he realized that the person was ripping him off because the crown was not made of pure gold. Because if it was made of pure gold, it would have a particular density. I think it's like 19.7 grams per centimeter cubed, if I remember correctly. So if we were to imagine that we dumped one of these samples in water and the volume was displaced and it came out to about 8.9 milliliters. Now we can work out the density. So we know density is M over V. So 24 grams over 8.9 milliliters. Okay, so if I work that out, 24 divided by 8.9 on my calculator, I get 2.7 grams per milliliter. Now, you'll notice that that number matches up with this. So my substance is aluminum. Remember that milliliters is equivalent to centimeters cubed. So this isn't the same as saying 2.7 grams per centimeter cubed. Okay? So by using density, we could figure out that this unknown sample is actually aluminum. Okay, so those are 4, relatively easy questions about density. In this document on density, you will see density problems. So you can try them out. All right. Some you'll have to figure out the volume, like this one over here. You have a rectangular solid, you have the dimensions, so you have to obviously work out the volume. Or sometimes the volume is given. So try these questions out. Some of them are a little bit challenging, so if you get stuck on them, we haven't really covered the more challenging aspects of density, then don't worry about it. Just try them out. On Friday, we can go over them and we can look at some more challenging scenarios. The answers are below, so you can always check your answer, okay? Let me switch gears now. I'm gonna actually pause the record button. I don't know why I say record button. And I'll take any questions and then we'll move on to the Kahoot. Here we go. Ready? This is a good way to review, so let's begin. Are you ready? Remember your Bohr Rutherford diagrams. Not the first ring, but the second ring. Yeah, that's right. See, the first ring is 2 and then 8 after that. Very good. Okay. Oh, that sense really quick on the draw there. Excellent. Okay. Which of the following have approximately the same mass? Protons and neutrons. The atomic mass is just protons and neutrons. Very good. Oh, Ellen takes over the lead. Okay, what is this symbol for? Oh no, I put the same answer twice. No! How did I miss that? Oh no. Oh boy, I feel bad for people who pick green. Sorry, I apologize. Oh, no, sorry about that. Can't believe I did that. Yes, very good. Atomic number. All right, let's keep going. Which of the following is false? Which of the following is false? Yeah, can't have 14 electrons. Remember, it has to have the same number of electrons as number of protons if neutral. It could have more or less if it's not neutral, but it can't have 14. That would be way too many. All right, here's our top 5. Let's keep going. Which is true? I'll give you a hint. It's a gas. Very good. So if it's a gas, it can't have high density and it cannot conduct electricity well. So that eliminates 2 possibilities. Okay. Some of the experiments we discussed. The gold foil. Ernst Rutherford. All right. Next question. Essence back in the lead. What happened in this experiment when they were hit by the helium nucleus? Those are the alpha particles. Yeah, most went right through, which says the atom is mostly empty space. Next question. Bohr Rutherford diagram. What's the best description? Yeah, very good. Electrons are in rings around the tiny dense nucleus. All right, Emily's back in the lead. Marianne is on fire here. Named after the sun. Helium. So it seems that I was supposed to have changed the times to 30 seconds, but for some reason it didn't save that change. So unfortunately, it looks like you only have 20 seconds to answer these questions. So you're going to have to be a little bit faster, okay, girls? Here we go. Oh, we got a new leader. All right, number 11. Very reactive, wants to lose 1 electron, contains almost all metals, except for 1. It's on the left side. Yeah, the alkali metals. All right.
Oh, look at that. Okay. You need two answers here. Use this to discover the, remember this? The cathode ray tube. We can eliminate possibilities if you remember the particle that was discovered. Yeah, it's the electron with Thomson. So try to reason out. I know if you can't remember everything, you should be able to eliminate possibilities where possible, obviously. Okay. Let's keep going. Yeah, still in the lead. Trying to hold off Emma now. One of the first, can't spell suggest. Who suggested the existence of the atom? Think back, thousands of years ago. Greek guy. Democritus. That's right. Aristotle did not agree with him. Okay, let's keep going. We're almost halfway there. Periodic law. Think about the periodic table. A Russian fellow. I might give it away. Dmitri Mendeleev. And their periodic law was the accident. Well, incorrectly put the masses, the elements by their mass. It's supposed to be by their atomic number. Okay, Monica. Oh, all of a sudden comes out of nowhere. Good place. Not part of the atomic theory, which is not part of the atomic theory. Yeah, that's part of, this is part of the particle theory, which is almost the same as the atomic theory, but it describes how things, move, for example, or bonds form. So it's not the same theory, although there is overlap. All right, let's keep going here. Blood. How would you classify it as? I'll give you a hint. It's not homogeneous. It would be heterogeneous. A mechanical mixture. Very good. All right, keep going. All right, death match here at the top three. Okay, let's keep going. Which of the following would not be homogeneous? So they would be heterogeneous. Or in other words, they wouldn't be a pure substance in this case. That's a hint. Yeah, because air is not a pure substance either, but air is homogeneous. Milk. Yeah, milk is heterogeneous. I can actually see different things in it when you look closely enough, though. Here we go. Next one. The period, which is not the same as the column. Column is up and down. Yeah, the period is also the row. Very good. Oh, Emily takes over the lead. Number 19. Who discovered the neutron? If you don't know, use the process of elimination. Okay, Chadwick was the discoverer. Very good. Okay, let's keep moving. Keep moving. Number 20. Physical property. refers to pulling things into wires. Ductility is the ability to pull things into wires. Next. So the following is false regarding this, which is a combination of copper and tin. Now we're looking for which is false. It's not a pure substance. It would be actually a solution. That's something called an alloy. This is bronze. Bronze is a combination of copper and tin. Okay, next. Okay, it's getting close up there again. Which of the following is not a physical property? In other words, it would be a chemical property. Yeah, combustibility, reaction with oxygen. All right. Oh, Emma takes over the lead. All right, number 23, 8 questions left. When neutral, the number of electrons in iron is? Same as one of those two numbers. Same as the atomic number. All right, next question. Regarding iron again, how many neutrons would it have? Remember the formula for that. It would be the mass number minus the atomic number. Yep, 56 minus 26 is 30. All right. Okay. It's pretty tight up there. All right, let's keep going. What is false regarding this element? Being iron again. What is false? You know, I apologize. I made a mistake on this question. Oh boy, sorry. It didn't. I made some changes. It obviously didn't record my changes. Sorry, girls. That's not correct. Well, that is false, but it's also this other statement is false too. It wants to gain electrons is also false, and it is not malleable is also false. The question should have been what is true regarding this element. It didn't change it. Oh boy. Oh boy. All right. That's okay. All right. So this was supposed to be what is true regarding this element, and the answer is it is dense. But obviously, for some reason, it didn't record my changes. Frustrating. Okay. Next. What is this showing? Yeah, it's so you have on the left, clearly see the particles have changed. So whenever you rearrange particles, that would be a chemical reaction. Okay, next question. There we go. Which of the following is true regarding this image? Yeah, so they don't have the same mass. You can see that they have different masses, but they are all hydrogen, so it's the same. They are the same element, they're not different elements. And they obviously don't have the same number of neutrons if they have a different mass. So these are examples of isotopes. Okay, how many questions? 3 left. Which of the following statements is true? Think about particles and how we use that to describe pure substances and things that are not pure substances. Yeah, so if you look at A has the same particle, all 4 are the same. If you look at B, we can see different particles, so B would be not a pure substance. A would be a pure substance. All right, so 2 questions left. Here we go. Emily's back in the lead. Okay. Mathematically, that adds up to 103 grams. 10 plus 40 plus 53 is 103. So what law are we describing here? Conservation of mass, right? The mass is the same before and after a chemical reaction. That's the conservation of mass, law of conservation of mass. All right, last question. Here we go. Last one. Let's see if Eleni can hold off Emma or Mariana here. Okay, if it has 10 electrons, then what would it be? It'd be negatively charged. So can't be so whenever nitrogen has 7 electrons, 7 protons, because this number 7 in the periodic table, you can't change the number of protons. Because if you change the number of protons, it's not nitrogen anymore. It's something else. It would be, in that case, neon. So our winner is Eleni, Emma, and Mariana, top 3. Armina and Essence are runner-ups. Very good, girls. Excellent. And I totally apologize for that question about iron. Obviously, I made some edits. It didn't save my edits. That could have hopefully, but it might have cost someone. Okay, Olivia says she couldn't play. I know some of you weren't able to play, but you could still use this as a way to review. So let me stop recording and take any questions, okay? But you can still use this as a way to review concepts in the atom, okay?